Okay, today we're going to talk about factoring. Start off with, we're going to continue on with what we were doing with greatest common factors. Before we just found the greatest common factor, now we're going to take an expression like this one, 9x squared plus 36x, find the greatest common factors of each of the terms, and then write this expression the way it would have looked before you used distribution. Okay, so we're kind of undoing distribution. Okay, so if we want to walk all the way through this, 9 is the same as 3 times 3. X squared is x times x. 36, you can say, what? 2 times 3 times, well, 2 times 2 times 3 times 3. 1 times 2, yep. Okay, and then times x. So you can kind of look at this and go, well, what things are common? Well, there's 9 that's common, because there's 3 and 3. There's 1x that's common between the two of them. So it must be 9x. It would be the GCF, the greatest common factor. So if I were to take out a 9x from each of these two terms, okay, if I take a 9x out of 9x squared, I'm only left with an x. And you can think of that as backwards of multiplication. If I take 9x times x, I get 9x squared. Okay? And then I need to add something that will give me 36x. Well, 9 times 4 is 36. So I need a 4 here. Okay, and then we can check this. Okay, so let's check by distributing. Okay. So we've got 9x times x plus 4. We distribute. 9x times x is 9x squared. 9x times 4, 9 times 4 is 36. 36x. And that is exactly where we started. Okay? Now, we should be able to cut out this middle section and kind of figure that out on the fly. If we can't, then that's fine as well. Okay? Oops. This is our answer here. Okay? 9x parentheses x plus 4. So those are the two factors of 9x squared plus 36. Okay, let's look at another problem. Okay, what is common between all three terms? Well, there's at least a 2. Okay, 2 comes out of everything. Okay, this one has a cubed. The first term has a cubed, then a and a squared. So you can at least take an a out. Okay, you have b squared, b, and b cubed, so you can also at least take a b out. So I should be able to take a 2ab out of that. Okay, if I take a 2ab out of the first term, I'm left with 2. Nope, I've got rid of my 2. So I'm left with a squared, because I took an a out. And I'm left with b. So I take a b out of the b squared, and it's just a b. Okay? Take a 2 out of 8, and you're left with 4. Then remove an a and remove a b, and that one's finished. Nothing else left. Okay? In the last term, take a 2 out of the 16, you get an 8. Take an a out of a squared, and you're left with an a. Take a b out of b cubed, and you're left with a b squared. Okay? And again, if you want to check it, you can check it using distribution. Just distribute the 2ab through all of the three terms. Okay? And it should work out correctly. Okay, so that's factoring using distribution. Okay? Now this is very similar. We're still going to factor using distribution, but we're going to group things together. Okay? There's 4 terms here, and if you look at them, 5, 15, 4, and 12, there's nothing that's common between any of them. The 12 doesn't have a y on it, so there's not a y. The 5 doesn't have, the 5 and 15 work, but the 4 and the 12 don't work with the 5 and 15. So we're going to group these with things that they're similar. So I'm just going to put parentheses around two different groups. Okay, now I'm just going to look at the first set of parentheses and factor out of that. Well, 5 comes out of both 5 and 15, and y comes out of both y squared and y. So if I take out a 5y, I'm left with y minus 3. Okay, in the second group, the only thing that comes out is a 4. So I need to leave my plus sign there. Get a 4 outside. Okay, if I take a 4 out, I'm left with y minus 3. Okay, now if you look at this, this is strange, but I've got the 5y times y minus 3, and I've got a 4 times y minus 3. So technically, I can factor this again. Okay? Out of this group, I can take out a y minus 3. And this group also has a y minus 3 in it. So I'm taking out a y minus 3. Okay? And what's left? Well, if I take a y minus 3 out of this first group, I'm left with a 5y. If I take a y minus 3 out of the second group, I'm left with a 4. And it's a positive 4. Okay, so in the end, I get y minus 3 times 5y plus 4. Okay, and if you notice, we use distribution, but what we ended up undoing is foiling. Okay, because now I've got two binomials, so to check this one, you would need to FOIL. Okay? So you can't just distribute this one to check it, you have to FOIL it. Okay, let's look at solving a couple. Okay? There's a rule in math that if two things multiply to be 0, one must be 0. So if you multiply two things together and the result is a 0, then one of those two things must have been a 0. Okay, so here we're multiplying two things. We're multiplying an n minus 4 times an n plus 2. So technically, one of these two things has to be 0. Well, we don't know which one. So we're going to say that either n minus 4 equals 0 or n plus 2 equals 0. One of those two things has to be true. Okay, and now we just solve them. So this one, n minus 4, we need to add 4 to both sides. So n equals 4, or over here we need to subtract 2 from both sides. N equals negative 2. And I have two solutions. Okay? Okay, so if two things are multiplied, one of them has to equal 0. So we use this word or in between there. Okay, let's look at one more of those. This one we actually have to factor and then we will solve it. So we need everything on the same side. To start this off. Okay, and I'm going to keep the 3 positive, the 3m squared positive. So I'm going to subtract 5m from both sides. Okay, now everything's on one side. Now I'm going to factor. So I guess I could. So now I'm going to factor. Okay, so what comes out of both of them? Well, 3 and 5. They don't have a greatest common factor other than 1, so we can't take that out, but there's an m in both of them, so I'll take an m out. Take an m out, I'm left with 3m minus 5. So, we go back to our rule, we're multiplying an m times 3m minus 5. So either m is 0 or 3m minus 5 is 0. So the last step here is to solve it. Okay, and to solve that, we're going to break this apart. So either m equals 0 or 3m minus 5 equals 0. Okay, how do we solve these? Well, this one's done. Okay, this one, add 5. Divide by 3 on both sides. And we'll just leave that as a fraction. Okay, so our solutions, and we can write it this way, m equals 0, comma, 5 thirds. You can put the comma in there, you can put an or in there. Okay? So that's an introduction to factoring using the distributive property.